Hey guys, today you're going to learn about one of the basic fundamental things in chemistry. This picture that you have on your paper, this is an atom. And so we're going to learn about what makes up an atom, and those things are subatomic particles. So all subatomic particle really means is just what are the parts of an atom. So you might have heard of these before. There are three parts of an atom. There's protons, there's electrons, and there's neutrons. Those are the three different subatomic particles. So we're going to talk about where they are in the atom. The proton lives in the nucleus. So if I label that on my diagram, I'm going to make my protons green. The nucleus is right here in the middle of the atom, so that's where I would find protons. The charge of a proton is positive, and they have a mass of 1 AMU. Now, AMU stands for atomic mass unit. Basically, because atoms are so small, they couldn't use grams or anything, so they made up this imaginary AMU unit to measure the size of these different subatomic particles. Okay? Protons will always equal, you'll know the number of them based on the atomic number of an element, and in a little bit I'll show you where that is on the periodic table. Our next subatomic particle are electrons. So I'm going to make my electrons blue. Electrons are found in the energy levels. An easy way to remember that is that they both start with E. So electrons, energy levels. Now energy levels are these rings around the nucleus. So I could find electrons floating and circling and orbiting around in any of these energy level rings. Okay? Maybe you remember this, the charge of an electron is negative. They are so little that they actually don't have a mass, so we say that the mass of an electron is 0 or none. You'll know the number of electrons, it will equal the number of protons, as long as it's a neutral atom, and that's what we're going to deal with for the most part for a while. We'll change that later, but for today, let's say that electrons equal protons. Our last subatomic particle is the neutron. Those are also found in the nucleus, so they live with the protons. So if I make my neutrons red, I would squeeze them inside of the nucleus with the protons. The charge of a neutron is neutral. Notice the beginning of both of those words, neuter, right here. Neutrons are neutral, so it almost matches the word, which will make it easier for you to remember. Neutrons are about the same size as a proton, so they also have a mass of 1. And the way that you're going to calculate this is you'll have to do a little bit of math. You're going to find out what is the mass of the whole atom, and then we'll minus or subtract the number of protons that there are. And we'll do some practice with that, so don't worry about it quite yet. There are a couple other parts of this atom, and we already mentioned a few of them, but I want to make sure that you really know what's going on with them. The nucleus is a small dense core that holds the protons and neutrons and has a positive charge. So if I was going to label that, this circle right here is the nucleus. That's where the protons and neutrons are found. Another part that we already mentioned are the energy levels. Those are the paths around the nucleus where the electrons travel. Because electrons live there, that's what gives them a negative charge. So all of these rings around this atom has 4 energy levels. That's where I would find the electrons. Now, this part can be a little tricky. So we have something called atomic mass. So if you look at the periodic table, there's going to be a number there, it's going to have a decimal in it, and that's the atomic mass. If I ask you for that, just copy the decimal number down from the periodic table. Now, if I ask you for the mass number though, I want you to take the atomic mass from up here, and I want you to round it to a whole number. Okay? So the difference is the atomic mass will have a decimal in it, and the mass number must be a whole number. You have to round it. That's why we've been practicing rounding so much. The reason why is you're going to take that mass and use it in your neutron calculation. When you do mass number minus the protons, that's how you'll calculate the neutrons that you need. So this is something really, really important that you need to get in your head, this little formula. Alright, let's do some practice with this. If you look at the little nuclei that you have on your paper, what I want you to do first is just do some counting. On your paper, you've got the number of protons and you've got the number of neutrons. So I just want you to go through and count how many protons and neutrons you see in each atom, and just fill in those two columns that I've highlighted first. Okay, did you count? In A, there were 5 protons, 5 neutrons. In B, there were 6 and 6. C had 8 and 8. D had 4 and 5. So notice up to this point, the proton and the neutron number were equal. It does not have to be like that. In atom D, it is okay for the protons and neutrons to be different numbers. That's fine. E is also different, and that's okay. In F, the proton and neutron number is also different, and that's fine. Now let's talk about how you use this. They didn't give us electrons to count, but we can figure it out. Remember, protons and electrons, oh, let me highlight that in a different color. Protons and electrons in a neutral atom have to be the same. So this column of protons will equal this column of electrons. The next column I have to fill in is the atomic number. So remember, atomic number also equals the protons and the electrons. So those ones that I've highlighted yellow, those columns all have to be the same. Okay? For the mass number column, we're going to have to do a little bit of math. Okay? Mass number, let's make it so you can read it. If we did the mass minus the protons equals the neutrons, that's the formula that we want to have in our head. Okay? If I look at the first atom, I don't know the mass, that becomes X. I do know the number of protons was 5, and the number of neutrons that I had in that atom was also 5. So I used those numbers from my chart, and now you just have to solve for X. If you like the river, do this, add 5 on each side, X equals 10. So the mass number for this atom is 10. Alright, if you got that, go ahead and figure out the rest of the masses. If that was a little tricky, I'm going to do some more examples. Alright, if I look at atom B, I need the proton number and the neutron number. So it had 6 protons and 6 neutrons. I am looking for the mass number, so that's where I put the X. 6 protons, 6 neutrons, draw your river and solve. The mass number of this atom is 12. Alright, so let's do one more together if that's still a little bit tricky. If you're good, go ahead and fill in the rest of that column. Alright, for atom C, I need the number of protons and neutrons. I know the proton number, I know the neutron number. I don't know the mass number, that's where X goes. 8 protons, 8 neutrons, draw your river and solve. The mass number of this atom is 16. Alright, so now fill in the rest of that column and let's see if you can check your answers and see if we agree. If any of those look a little bit funny to you, don't be afraid to come on and ask. Alright, we're going to do the last column now. In order to figure out the symbol from the periodic table, we have to figure out which of the numbers from up above are we really going to use. Which one of these columns that we have will identify it on the periodic table. The answer, the thing you're looking for, is it's all about the protons, which is the same as the atomic number. So grab a periodic table, and we are going to compare the atomic number, or the number of protons, and figure out what element that is for real. So if I look at the first atom, it has an atomic number of 5. So on my periodic table, the element with an atomic number of 5 is boron. So this real atom is boron. The next atom has an atomic number of 6, so it must be carbon. The next one has an atomic number of 8, which must be oxygen. The next atom has an atomic number of 4, which makes it beryllium. Atom E has an atomic number of 1, so it is hydrogen. And lastly, we have an atomic number of 8, which is oxygen again. So, there's a little bit of something funny going on here, because we see oxygen in here twice. Oops, except I didn't write oxygen. It is okay for oxygen to be in here twice. The difference is the number of neutrons. Now it's okay to have a different number of neutrons because they are neutral. It doesn't matter if you add any extra neutrons or not. It's still oxygen because the atomic number is 8. So let's do a little bit more practice with these real atoms now. Okay, so have your periodic table handy. We're going to find the atom of boron. So that is right here. Okay, let's see if we can use that to fill out this information for it. P means protons. Protons equals atomic number. The atomic number for boron is 5. So that means automatically I also know the number of electrons, and I figured out the atomic number. Those ones always have to be the same. To figure out the neutrons, remember, you're going to do mass minus protons equals neutrons. And we don't even have the mass for this yet, so let's figure that out. Atomic mass is going to be the decimal, so I'm just going to copy that 10.811 from the periodic table. In order to make it a mass number, I'm going to round it. To make it a whole number, you round it the ones place. The 8 is going to make it round up, though. The mass number is 11. Now we've got the mass minus the protons, which was 5. The number of neutrons that this thing has is 6. Alright, the group and family, remember group and family is column up and down. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Group or family 13. The period is the row across. So 1, 2, second row down, so period 2. And then we have to figure out, is it a metal, a non-metal, or a semi-metal? So remember your zigzag is here. If it's touching that zigzag line, which boron is, it is a semi-metal or metalloid. Alright, if that was pretty easy, go ahead and try the other examples on your own. If that was a little bit hard, I'll do some more with you. Alright, let's look at calcium together. So calcium is here. Okay? The first thing I need is the number of protons. That's the atomic number. The atomic number is 20. So that also equals the number of protons. Actually, let me do it so the colors match. And remember, protons will equal electrons, so that's also 20. Next, to calculate the neutrons, I need to do mass minus protons equals the neutrons. Got to figure out what those masses are. Atomic mass, remember, is the decimal. So if I copy that, it says 40.078. If I want to make it a mass number, I'm going to round to a whole number. It's going to stay at 40 because of the 0 afterwards. Now I have what I need. The mass is 40. Protons 20 equals x. Solve for x. The number of neutrons that we have is 20. Now we just have to figure out the group family period. Remember, group means column up and down, or family. It's in the second one over, family 2. Period means row across, so 1, 2, 3, it's in the 4th period down. And for metals versus non-metals, I need to look at the zigzag. Remember, that's over here. Everything on this side is a metal, which makes calcium a metal. Alright, I want you to try the last 2 examples on your own, and then come back and compare with me. Alright, let's see how you did on these 2. Phosphorus, the element is right here. Its atomic number is 15, which also tells you the proton and electron number. If I want to figure out the masses next, the atomic mass is the decimal of 30.974, which rounds up to 31 for a mass number. If I do mass minus protons equals neutrons, 31 minus 15 equals x, x equals 16. That's my number of neutrons. The group family, if I count over, that is column 15, period 3. And it is on the right-hand side of that zigzag line or staircase, which makes it a non-metal. And lastly, let's try iodine together. Okay, so if I look for iodine, I can find that right here. That's that capital I. The atomic number there is 53, which also equals the protons and the electrons. In order to figure out the neutrons, I need to deal with the mass. So the atomic mass is 126.90. For the mass number, if I round that, it becomes 127. Now I can use that. I know that mass minus protons equals neutrons. The mass is 127. The number of protons is 53. If I solve for that, I get 74. That's my neutron number. Lastly, I want to figure out where on the periodic table it is. The group in the family, remember, is the column upside down. If I count over, that's number 17. Period is what row it's in, so 1, 2, 3, 4, 5. Period 5. It is also on the right side of the zigzag line, so it is a non-metal. All right, let me know if you have any questions, and now you have a whole other page of practice to do on your own. Good luck!